Piotr, can you hear me?
Yes, I can hear you. Hello.
Perfect stuff. So, Piotr, if you share your screen is shared already, so let me add that in. And whereabouts in the world are you, Piotr?
Well, a few words about me. I'm self-employed as a remote freelance software gardener, and this is actually the place where I've been working for the past few years. I also work as a trainer for a few companies, one of them being Semanthis, and I also give talks about Java architecture and stuff. Actually, today I was supposed to give a talk on DevOps France about Java 14 to dive deeply, but unfortunately this can't happen. So fortunately, we have this online conversation today.
Absolutely. So you've got 30 minutes now. We'll have some Q&A before the end of that, and I'm going to hand over to you. For the next talk. Thanks very much.
Thank you. So just to finish talking about myself, it's I've been with Java since 1.3 and even backported some code to 1.2. So you see, I'm haunted by Java even when I'm on holiday. So I think I've seen quite a few releases and quite a few, my share of new features being released. That's why today I'd like to show you one of the new features in Java, which is records. And just before we start, a little safe harbor step in from my side. So just don't trust ultimately everything you see on the internet. Try to verify on your own. And okay, so records in Java. They are a preview feature in Java 14, of course, which was released like not even a month ago, I think. And they are implementation of JAP 359. And to play with records, to understand records, to get a taste of them, you need to enable preview features. So it would take too much. So I just prepared 2 links for you, and the slides will be shared, of course, after this talk. So you can check out in slides, or you can also check out a video from DevOps Belgium previous year when I explained how to enable them, what's important, what's not important. I'll just show you quickly how to do that in IntelliJ. So you have your project, you go to your project, and then you go to module settings, and in the module settings you have to select here the language level as 14 preview. You have to accept a kind of a agreement that you know what you're doing, that you're saying, and so on. So it has to be 14 preview. That's available in 2020.1, and of course you need to run it using JDK 14. So unless you don't have it installed now, you will have to do that. So one option to do that is just to go here and now click Add SDKs, and you can select Download JDK, and see you can select Adopt OpenJDK or Adopt OpenJDK 14, and it will get downloaded to your home folder, and you can use it, you can run it. So it's really like installing new Java versions. It's really a breeze, and it's not an issue to do that every 6 months. So once you have the preview features enabled, you can play with records, of course, also text blocks and other cool stuff. But today we're focusing on the records. So what are these records? They are a new kind of type declaration in Java 14, and record is a restricted form of a class. So kind of like a enum, for example. And of course, they implement, if you have a class which is a record, all the instances implement, and the class implements Java lang record. And this is the way you declare them. So instead of saying class, you just say record. Then you put the name of the record you'd like to have. And then you go pretty much like, for a method declaration or a constructor declaration, you select the type and the name, the type and the name, and so on. So I think we'll do it this way. I'll try to go through the slides quickly, and then we'll dive into the code, because I think the code might be even more interesting than the slides. So what records have? They have a name, of course. As you have seen, the previous record was named complex. By the way, it's about this, complex number. You can see here on Wikipedia how it works. It's just not 2D point. It's a number, and so on. So you can add them, multiply them, and so on and so on. And let me go back here. So they have a name, and they have record components. They don't have to be any record components, but then it would work. I'm not sure if it makes so much sense to have a record without any components, aka fields. So I guess you'd like to have some. And then these record components become actually private final fields. So records are immutable on the shallow level. So you cannot alter the field once your record instance has been created. And they also have generated accessors. So we have, thanks to these accessors, a way to get values from these fields. And they have generated constructors, compact one and canonical one. We'll get to that, what that means. And they also have generated methods like equals, hashcode, and toString. And they take into account all these components or fields you've declared in this record. What records can is they can also define constructors, meaning you can redefine a compact or canonical constructor. You can also have a custom one if you really need to, due to whatever reason. And they can also have their own implementation of generated methods. Say you can provide your own implementation of equals or hashcode or the accessors or toString, if that's really needed. They can also have extra methods. You're not limited. You can have any other methods if you think your record needs fancy method, then you can add it. And they can also have static fields and methods, like constants and static methods. So, and they can also implement interfaces. So there's no limitation in here. What records can't is that they cannot extend any other class, or they cannot be extended, pretty much like enum. Your enum cannot extend any class, and an enum cannot be extended. It's just like enum comes directly from Java-lang enum, and records come directly from Java-lang record, and that's pretty much it. You can use interfaces if you need more inheritance. They have no setters, and they have no getters. I mean, these are not generated, and theoretically you could create some, but I mean, to act like ones, but then I think you would just deny the purpose the records were introduced or brought to Java. And they cannot have any extra instant fields. So what's declared in the record declaration becomes a field, and you cannot have any other extra fields beside that. So records. And this is maybe a thing that confuses lots of people, because people were saying, there were all these flame wars on Twitter and elsewhere that we don't need any more JavaBeans, we don't need Project Lombok and so on, because records. I'm not so sure. Records are not JavaBeans. Records are records. They don't follow this JavaBean convention because they don't have getters. They have accessors. And what they are exactly this. They are POJAs, plain old Java objects with accessors, but not getters. And maybe it's easier to you if you think about them as named tuples. So in some programming languages, or like in a SQL, we have tuples. And these tuples are not anonymous, but like pretty much everything in Java, if not everything, they have a name. So your record has a name as a class, and then all the components, they also have names. So everything is named. That's why they named tuples. This is the way to think about records. They're not JavaBeans, they named tuples. Records can be nested, and that's really useful. That's very handy because they can be nested pretty much like static classes. So they don't have, reference to a state of the author class, of the class in which they are nested. And they are very handy in this way for streams like reduce and collectors. There was always this thing that, let's say, we don't have any out parameters, and returning value by a parameter is really let's be honest, it's a kind of ugly approach. So we weren't able to return like three things and so on from a single method invocation. So that's why we returned arrays, collections, or sometimes we had a custom beans. And now we can just use records, which are easy to define, and we don't need anything else. That's where they come really handy. And reflection of records. Yeah, so we have a new method in a class, and it's record. It's linked to the Java doc, so I think you can follow that. So just like we have isEnum in class, now we have isRecord, which means you can call it and check it if the object you have in hand is a record or not. And also we have getRecord components, because they're not JavaBeans, they have components. So this is the method you should be using, and this will give you an array of all the components being used. But one thing to remember before you try to do anything with reflection, watch this. Yeah, so please don't overuse reflection. I mean, you violate OOP and stuff. Sorry, I had to stop it. Okay. And serialization of the records. I mean, records are serialized in a bit different way than in the other objects. I mean, the serialization is like nothing fancy, but they are reconstructed using the constructor. So it's the constructor that's going to be called again when you have to deserialize your record object, basically. And what's maybe even more important is that libraries and frameworks kind of need to adapt, because they are not bins, they have no getters, they have accessors. So they need to be aware of this is record and then fetch the record components and so on to get perhaps get them working properly. I mean, like JPA, JSON, JSON and stuff. Okay, so let's go to the code. So see, this is a little program I'm using for records. So I have two complex numbers, and this is a let's give it a spin. What's going on? Okay, now I know. I hope I know. Okay, yeah. So it's running. It says hello records, and we have these two. I mean, this is the result of the multiplication, and this is the we have just this complex, and it got printed here. See, very nicely. So let's go to this complex record. See, it was declared as a record. So it has two components, a real part and imaginary part. We can define extra methods like add, subtract, multiply, and so on. And we can override this string method, but it's not necessary. If I don't do that, and we run this program again, see, now you have the default implementation of the complex being shown or used in this print line. So this is basically how you can create your record, and you can toss some extra methods if you really need to. Yeah, so let's take a look at some valid examples of records. So like I said, you can have a record without any field or a component. You can have just one. You can have custom methods. You can also have static members like a field or a method. By the way, the code is online. Don't worry if I'm going too fast, because we have a lot to cover. Then you'll be able to walk this code through again. Don't worry. And of course, we can do something like this. So we can you have a deep mutable field. I don't think it's good approach, but technically it's possible. It will compile, it will run, and we can have custom to string method like in here, and we can also override equals and hash code if really needed. But please remember, they need to obey their contracts. They have to be symmetric, transitive, and stuff. And we can also override the accessors if we need to, because let's say we would like to have a side effect. I don't know why would you need to have a side effect, but let's say you need to have a side effect in an accessor, then it's still possible to override this or create this accessor on your own. And then we have these constructors. You see, based on this record declaration, custom canonical constructor, I have here 4 components, A, B, C, and D. And let's say I'd like to assert that A is not equal to B and C is not equal to D, because business logic. And then I don't need to even do that, but I can do that. I mean, then I'm overwriting this canonical constructor, and even IntelliJ tells me it's not needed because it's grayed out. And of course, I can have some side effects just, for the sake of demonstration. But we can also have, you see, not this canonical constructor, which is pretty much too verbose because it's repeating this code over and over again. So we can have this compact format, which doesn't have this argument list at all, and pretty much is the same logic. So we don't have to call this and repeat this argument. Still, it's going to act the same way. And we can also have custom. If you really need to, you can have custom constructor like this. So see, I have 2 integers, length and hash, and I'm going to call them with a string, and then I can take a length and hash code of the string. By the way, if you haven't noticed, we can't name a component as a hash code because of the method name clash, of course. So that's why it has to be remain hash. And records can implement interfaces here. This one is implementing comparable. So see, you can do pretty much a lot of stuff. what we can't do is they cannot extend anything else. See, I cannot extend Java util date. I mean, that would be a stupid idea anyway, but let's say I'd like to do that due to whatever reason, I can't do that. And also classes cannot extend records, like records are final. And they don't, you don't have an option to have an extra field. See, it's not going to compile. What does it say? Yeah, make static. See, so it's possible to have static fields, but not regular instance fields. And of course, we can't have anything like getters. Let's say we'd like to mimic the approach with accessors. So we'd like to have something like setter or something setterish. We can't define this. It's not going to work because this is a private final field. So it's impossible. Yeah, else this code is going to run, I hope. Yeah, see, it says I'm accessing 12 because here I'm accessing the no setters field, which is 12 because here it's initialized as 12. Okay, so let's talk about the, yeah, nesting. I think nesting is quite nice feature, and this is actually, I think, the primary usage of records. I mean, this is what I would expect to see in real code, you know, like deployed to production after a year or something like now, when records are not the preview feature anymore. And perhaps we'll have a pattern matching, you know, with the composition and stuff. For now, we don't have it. Anyway, see, just as I have this inside class, and it's if I make it static, I can't access this enclosed field from the enclosing class, like this field. I can't do that, and pretty much the same works for records. You see, it's impossible because this would mean that the state of this enclosing class would leak here, and it doesn't have to be final. Sometimes, I mean, it could be mutating and stuff. So that would make this record depend on the state of the enclosing class. That's why this is illegal. So nesting records is like nesting static classes, more or less. And when it becomes handy, I mean, this is the example I used for team collector of Java 12. And previously, I had to have this boilerplate code just to, you know, perform the reduce operation. So I had to have the count and sum, and yeah, now we know it's canonical constructor and this custom to string method to show the results. And now instead of this code, to make something like this work, so I'm just, you know, where I have a stream of integers and I'm taking two collectors, one counting and one summing longs. Now I can just use count and sum constructor, but it's not this code which is commented out here. See, this static class doesn't exist anymore. What I have instead is that in this main method, I mean, inside the method, I have defined this count and sum record with two components, count and sum. And this is a single line that replaces all these lines commented out below. So see, I can use them in reduce here to initialize as accumulator and as a combiner. See, it's going to work. And also here, when I'm using the team collector. So really, I think that nesting records to pass something like this, or to avoid, you know, this 2-element long array or something like this, is really handy. I mean, I would say this is the primary usage I see for records. Let's see if this code runs. Yeah, see, it runs. So we've summed up the numbers, we've counted them, and both the reduce and team collector produce the same results, and even the statistics, if we call the statistics from a long string. Okay, so we have still a few minutes before Q&A. So let's take a look about this reflection. So I have a simple record here, see reflection check, and I have just an enum, and I have a bean with setters. So this is just integer and string, and this is like UID and string. And of course, like, to make it really bin, I need a constructor, I need getters, I need a setter for the mutating field to string equals and hash code, like pretty much a lot of code. And here it's just everything I need, provided I'm not going to mutate this string. And of course, this is an integer and this is a UID, but it's not that important. What's really funny, I think, with this, like when you take a look, I have two objects. This is an enum and this is this record. So when I give him a spin, maybe we could run it. Yeah, you see that the first one is an enum, because I have this isEnum method on a class, and here I have this isRecord method on a class as well. And it says this thing created here is a record, of course, and I can read these record components, and they will give me, you know, the accessor methods, the values, everything. I mean, the code is down there. I mean, as for reflection, it's not the most beautiful piece of the code, but what's really important here is, like, when you take a look at this describe bin properties, and we are just trying to describe bin properties of the record and of the bin I have shown you just a second ago, then you can see that properties for this record reflection check, I mean, there's just one property, and this property is actually the get class method, and it's a single property following the JavaBeans convention, because every object, of course, needs to define its class, so it has to have this get class method. Whereas bin info for this bin with regular setter and stuff has more, of course, because see, it has not only this get class method, but it also has this get ID, and also has this set string field, and so on, and get string field, of course, because this property is a mutating one. So see, from this you know, bin info description, you can see that, again, records are not JavaBeans. They are something different. I mean, it's like comparing I don't know, peaches to apples. I mean, they're both fruits, they're both very tasty, but you can't exchange them in every receipt, basically. What might be interesting is, like, yeah, I have this serialization demo, so we can give it a spin, you can run it, and you can see that there's a slight difference in the byte format. But beside that, what's really important that we are going to deserialize here this just a record. And see, it says deserializing object, and here we have this object deserialized. And this line is quite interesting, because if we take a look in here, in this serialization record check, you see this is the code I'm calling in compact constructor, which means that this constructor is being used when the objects, which are records, are being deserialized. So it's not like fancy, clumsy methods. It's just a regular constructor. So I'm really happy that someone, and of course, by someone I mean the Java authors and architects, decided to clean this stuff up. And also we have this JSONification example. And it's one thing. Let's run it, because it might be shocking at the first time you run it. So basically, I have this bin, and I have this record, and what I'm trying to do, see, I'm having the mapper of Jackson from Faster XML, and I'm trying to write this value as a string, and it's working. By why it's working? It's working in the case of bin, because I have here something, yeah, I have this annotation JSON property on the field. I don't have a getter. See, the getter is commented out. And I have something which is like the accessor. So if I comment this out and try to run it again, it's not going to work, because Jackson thinks this bin has no properties at all. And we can fix that in three ways. We can have this constructor, we can have this accessor or any other method providing this as annotated as JSON property, or we can annotate the as JSON property just the field. This is what we can do, of course, beside custom deserializers and serializers and stuff. So let me uncomment this to run. And for this record check, see, this was handled properly by Jackson only because I had this annotation on the record component. If I get rid of this, it's not going to work again, because we are creating a record. But in this line, it's not going to work, because Jackson doesn't know how to serialize this record by default, because it's not aware of the records at the moment. I mean, at least this version I was using somewhere here in POM. And that's what version was that? Yeah, 2.10.3. So it wasn't aware of existence of records. That's why it couldn't serialize or deserialize records by default. So you see all these libraries like for JSON, JSON, GPAs and stuff. I think they need to adjust for something like this. And just a quick way to fix it is basically to annotate everything as, every component as JSON property. And then this annotation will be passed down both to fields, both to the accessor. So it's going to work like this. So I think it's pretty much okay. We're going to the Q&A, I guess. Just one thing before I finish, please always, and for everyone, not on this event and not only me, but every speaker, provide your feedback in any form. If you really wish, you can send me a paper card or just analog card. It's hard these days, but still it's possible. And this is a little poll. It's totally anonymous, so please go to this link. Tell me what you think about this presentation. Thank you. And here's the link for the code. And here we have the link for the slides and also my Twitter handle if you're interested in that. Back to the studio. Can you hear me?
We can indeed, and thank you very much for that. So it's Q&A time. So if you've got any questions, please drop them into the Slack channel or onto the Slido. I've got a question here.
Yes.
From Kuram. And Kuram asks, what problem is the new type record trying to solve? It seems very similar to class with some limitations.
I would say, in my personal reading, records are somewhere in between JavaBeans and enums. So this is the part of this story I've heard for generics. I've heard for enums. So, it just like for Java 5, everyone was like, "But the code is working. We're using it. Our code in production. Why would we need that?" I think it's to have less code, because you know how it works. You need to add a field, and then there are basically two parties. One party is using Lombok or any other auto generator to have a like beans with proper and correctly implemented equals hash code to string and so on, because these are generated. Or there's the other group of developers who say no, we're going to regenerate the methods on our own in our IDE. I'm just going to regenerate to string equals hash code, add these new getters and stuff. Thing is, whatever you do, it has its pros for sure, but it also has its cons. You need to remember you have to regenerate this code, and you have also a dependency to Lombok, which is not something great and not what you'd like to have in every project. Whereas for records, you don't have these issues. And if you'd like to avoid a large piece of boilerplate code, records are awesome. They're not most probably for GPA entities, but to return a few things from one method call, they're perfect. To use with streams, with collectors, with reduce, they're perfect. I see perfect fits for records. It's just they're not going to replace beans or other stuff. But just as we needed enums, we just weren't aware of this. I think we're going to use records. Moreover, what's coming in the future versions of Java is this pattern matching with destructors. So we're not only going to have these constructors, we're also going to have the deconstructors. So we will be able to match easily on records, I believe.
Okay. And do you know if the implementation of records will change? Because it's a preview feature.
I can't tell that. I don't see it in other people's brains, so maybe that's good. I can't tell that. I think there's certainly a risk that they will change. And moreover, I'm not sure if I would use them in production right now, unless I would be running the whole infrastructure, because I'm not sure if there are any cloud providers like, providing Java 14, unless, of course, you have your own Dockers and so on. And the other thing is that maybe if you rely on the implementation details too much, like for Java 15 or 16, you'll need to rewrite your code. So if you have a tiny microservice and you host on your own, why not? Why not give it a spin? That's why it's called preview features. So for us to preview and provide the feedback. But as a long-term investment in something you don't host on your own, or people are running it on your own, on premise, I'm not so sure records are meant to be used right now.
Cool. And do you think the use of records can improve performance?
Honestly, I don't know. I haven't checked that this way. I really don't know. I wish I could answer this question, but I would need to check. That's a good one. Good question.
Cool. Thank you so much for joining us, Piotr. It's been a pleasure to have you here. We're about to head into a break now for a quick refreshment. But please do remember that we're trying to raise money for the World Health Organization COVID-19 Solidarity Response Fund. If you want to help us out, we've already raised over $70,000 by doing this event. If you want to help out, you can head on over to aldertalks.org/tickets. Click the register button and buy a donation ticket. That's all you need to do. So have a nice break. Go grab yourself a refreshment, and we will see you again very soon when the Java track continues. Thanks very much.
Thank you.